You are able to move the ketchup packet by using the principle of buoyancy and by using pressure to alter its density. Buoyancy is the upward force that keeps things afloat, while density is an object's mass per unit of volume. Objects that have a lower density than the liquid they are placed in will float, while objects that have a higher density than the liquid they are placed in will sink. The ketchup packet has a small air bubble trapped inside, which makes it less dense than water, allowing it to float. As you squeeze the bottle, the water pushes against the ketchup packet and compresses its air bubble into an even smaller air bubble. When the air bubble is compressed, the density of the ketchup packet is increased. Its weight is the same, but it now takes up less volume. It is now denser than water, so it sinks to the bottom of the bottle. When you release the pressure on the bottle, the air bubble expands back to its original size, and the ketchup packet rises to the surface of the water. A paperclip, being a solid material, is more dense than water. This is why it automatically sinks. However, because of the cohesion forces on the water's surface, there forms a sheet-like layer. This phenomenon is called surface tension. In terms of physics, when the paperclip is carefully placed horizontally on top of the water, as to not break surface tension, the normal force the surface tension exerts on the paperclip is equal to the weight of the paperclip itself. But when detergent is added to the water, the surface tension breaks and there is no more force that counteracts the weight. Molecules in the atmosphere exert pressure on everything. When you first turn the cup upside down, the pressure of the air inside the cup and the air pressure outside the cup are equal. But if you look closely, you'll notice that just a little water leaks out between the card and the cup. This happens because the force of gravity naturally pulls down on the water. And when some of the water escapes, this causes the volume of air to increase slightly. Even though the amount of air above the water stays the same, the volume occupied by the air is now greater and the air pressure inside the cup decreases. The pressure of the air outside the cup is now greater than the pressure inside the cup and the card stays in place. All of this is possible because the water creates an airtight seal between the rim of the cup and the card. The candle heats the air and expands it. This cancels the depletion of the oxygen temporarily and the water level stays down. When the oxygen is depleted, the candle goes out and the air cools. The temporary temperature change delays the rise of the water. The volume of the air decreases and the water rises. The higher pressure is outside the container, pressing down on the water in the dish. The outside air pushes water into the container until the pressure is equalized inside and outside the container. The water stops rising when the pressure equalization is reached.